Today we're going to talk a little bit about functions. A lot of the functions that we're going to see in this section we already saw back in chapter 3. The only differences here our universal set is going to be the set of the real numbers. Unlike in chapter 3 when our universal set was that of integers and we put points on our graph but then kind of drew lightly in sketches with dotted lines. Here we're just going to figure out our values. We don't care if they are fractions or decimals or integers. And then we are going to use those to plot our points to get our graphs. So before we start going through the graphs, let's review our different types of functions. Right? So looking at this first function here, right? Yes, this is a linear function. Right? Linear functions do not have any domain restrictions. Right? Our next function is not linear. Right? It is a quadratic function. Quadratic functions also do not have any domain restrictions. Okay. Our next function is not linear. We have an absolute value function. Absolute value functions also do not have any domain restrictions. Okay. Our next function, not linear. This is a square root function. Square root functions do have domain restrictions. Right? So thinking about this particular case, our domain, remember that x plus 1, whatever's inside, has to be greater than or equal to 0. Right? So if we subtract 1 from both sides, that means that x has to be greater than or equal to negative 1. Our next type of function, also not a linear function. This is a rational function. Rational functions are the other type of functions that have domain restrictions. In this case, we just want to make sure that our denominator does not equal 0. So x minus 1 cannot equal 0, so x cannot be equal to positive 1. Our next type, right? Our last two equations are both the same type. Right? These are not linear functions, these are exponential functions. Right? We have an exponent in a variable, which we saw back in section 4.5. These are exponential functions. Right? There's no domain restriction for our exponential functions either. Alright, so we're going to go through and we're going to revisit our graphs. So to start with, this first one again is an example of a linear function. Right? We're in the form f of x equals mx plus b. We have a slope, we have a y-intercept. We could choose to use our shortcut and graph our line using just our slope and our y-intercept, or we can go through and we can calculate values. Right, so if we go through and we start calculating values, right, f of negative 3 is 1/2 times negative 3 plus 1. 1/2 times negative 3 is negative 3 over 2 plus 1, right, which is going to give us negative 1/2. Right. F of negative 2, 1/2 times negative 2 plus 1. Half of 2 is 1, so negative 1 plus 1 gives us 0. F of negative 1 is 1/2 times negative 1 plus 1. Negative 1/2 plus 1 is positive 1/2. F of 0, 1/2 times 0 plus 1. 0 plus 1 is just 1. Right. And then we're going to go through the last three. F of 1, 1/2 times 1 plus 1. 1/2 plus 1 is 3/2. F of 2, 1/2 times 2 plus 1. Well, 1 plus 1 is 2. f of 3, 1/2 times 3 plus 1, 3/2 plus 1 equals 5/2. All right, now we're going to go ahead and plot these points. I'm not going to plot all of them. I'm not going to worry about the ones that have fractions in there. I'm just going to plot the ones that give us a nice pair of integers. So we have -2, 0. We have 0, 1. Right, and we have 2, 2. Okay. Then we connect these dots to give us a nice straight line. So there is our graph of our linear function. All right, now moving on. Next we're going to look at a quadratic function. Right? So we're going to start by plugging in our values. Again, use these to create ordered pairs. Just remember, anytime we square a negative number, it turns positive. So f of -3. We're going to plug -3 in here. -3 squared gives us 9, minus 2 times -3 plus 1. That's really 9 plus 6 plus 1 gives us 16. F of -2. -2 squared is 4, minus 2 times -2 plus 1. That's really 4 plus 4 plus 1, which gives us 9. F of -1. -1 squared is 1, minus 2 times -1 plus 1. 2 times -1 is positive 2, so 1 plus 2 plus 1 gives us 4. F of 0. 0 squared minus 2 times 0 plus 1 is 1. F of 1. 1 squared minus 2 times 1 plus 1. So 1 minus 2 plus 1 gives us 0. F of 2. 2 squared is 4, minus 2 times 2 plus 1. 4 minus 4 is 0. 0 plus 1 is 1. And f of 3. 3 squared is 9, minus 2 times 3 plus 1. Right, well, 9 minus 6 leaves us with 3, plus 1 gives us 4. Okay. Looking at this, notice that some of our ordered pairs, the first two in particular, are going to be way off of our little grid here, so we're not going to bother to put those points in here. We're just going to focus on these 5 points. So we have -1, 4. We have 0, 1. 1, 0. 2, 1. 3, 4. Now we're going to connect these. We get a nice U shape. Remember, so this is a quadratic function. And quadratic functions have graphs that are the U-shaped, which are the parabolas. Right, our next function that we're going to look at absolute value. Right. So again, we're going to go through and plug these in. F of -3, absolute value of -3 plus 1. -3 plus 1 is -2. Take the absolute value, we now have +2. F of -2. -2 plus 1 is -1. Absolute value of -1 is +1. -1 plus 1 is 0. Absolute value of 0 is still 0. Uh, 0 plus 1 is 1. Absolute value of 1 is 1. 1 plus 1 is 2. Absolute value of 2 is 2. 2 plus 1 is 3. Absolute value of 3 is 3. 3 plus 1 is 4. Absolute value of 4 is 4. All right, so we're going to plot these points. -3, 2. -2, 1. -1, 0. 0, +1. 1, 2. 2, 3, 3, 4. What we see here, we see a nice V shape. So we're going to extend out from the V with arrows going continuously in both directions. So again, this is an absolute value function. Absolute value functions have V-shaped graphs. Right. So D, right, we are going to look at our square root function. And this is actually the same function that was listed on the table on that first page. And when we were looking at this function, remember that we said we had a domain restriction, right? Our domain restriction was that our x plus 1 that was inside our square root had to be greater than or equal to 0. That means that x has to be greater than or equal to -1. So what that means is, because of our domain restriction, we cannot find values for -3 and -2. Right? We can only start with -1. Right, so f of -1, square root of -1 plus 1, square root of 0 is 0. F of 0, square root of 0 plus 1, square root of 1 is 1. F of 1, square root of 1 plus 1 is square root of 2. F of 2, square root of 2 plus 1 is the square root of 3. F of 3, square root of 3 plus 1, square root of 4, which is going to give us 2. Right. Again, we could plot the ordered pairs that have the irrational numbers square root of 2 and square root of 3 in there, but we don't necessarily have to. We don't have to plot every single point that we obtain in order to get a shape of our graph. So we're just going to plot the points that we have here, the ones that are nice integers. So we have -1, 0, 0, 1, and 3, 2. Right, and then our square root, we're going to have a nice curve coming out to the right. We don't put an arrow on the other end because that's where our curve starts. Right? We can't extend past our domain restriction. Right, so next we're going to look at our rational function. So rational function, remember, are the ones that look like a ratio or have a variable in our denominator somewhere. Again, going back to the table on the first page, we did say that we had a domain restriction with our rational function. Our denominator cannot be equal to 0. So x minus 1 cannot be equal to 0, so that means that x cannot be equal to 1. This particular value gives us the line that is going to become our asymptote. Right, so our asymptote is this value of x equals 1 that our graph is not going to be able to cross. Right, we cannot have this for a domain value, so our graph cannot cross this line. Right, so now we're going to find our different values as we're going through here. So we're going to plug in our x values. So f of -3 is 1 over -3 minus 1, which is -1/4. F of -2 is 1 over -2 minus 1, which is -1/3. F of -1, 1 over -1 minus 1, -1/2. So we'll start filling these in here. -1/4, -1/3, -1/2. F of 0, 1 over 0 minus 1 is -1 over 1, which is just -1. F of 1, 1 over 1 minus 1, right, is 1 over 0. If we look at this, this was the value that we were not allowed to use as our domain. So we cannot plug in that value. Right, so even if you do forget and you try to plug it in, whether it's with this one or whether it's with a square root, right, this just shows that you can't accidentally get a value if you're supposed to have an asymptote there, if you're supposed to have a domain restriction. F of 2, 1 over 2 minus 1 is 1 over 1, which is positive 1. And f of 3, 1 over 3 minus 1 gives us 1 over 2. All right, so when we draw our rational functions, in this case we have one asymptote, so it's going to split our graph into two pieces. We have a bunch of fractions that are on the left side. Again, I'm not going to bother to plot all of my points. I'm just going to plot these two. So -1, -1/2 is one of our points, and 0, -1 is another one of our points. And our line of our graph, right, it's going to come close but not cross, right, both our asymptote and our x-axis. Right, our other points, 2, 1 and 3, 1/2. Right, so same thing here. We have points that are going to come close, but they're not going to cross our asymptote or our x-axis. All right, so the last two examples that we're going to look at, these are the only types of graphs that we have not seen so far. Right? And these are going to be graphs of exponential functions. Right? So I'm going to label my graphs for both f and g that they are going to be exponential. Right? So what we're going to be using here is we're going to be raising our different values to exponents. Right? So I'm actually going to kind of work backwards in this case. So I'm going to start with these bottom values and then work my way up here. So f of 3, right? 2 to the third power, 2 times 2 times 2 is 8. F of 2 is 2 squared, which is 4. F of 1, 1 squared, or excuse me, 2, f of 1 is 2 to the first. Sorry, I got my 1 and my 2 mixed up there. F of 1 is 2 to the first, which is 2. F of 0 is 2 to the 0. Anything to the 0 power is 1. F of -1, right, means 2 to the -1 power. 2 to the -1 means I have 1 over 2 to the first power. So this is why I started at the bottom and went backwards, because we're going to take our fraction that we got and we're basically going to flip it as we're going through. So right, f of 1, 2 to the first is 2, so 1 over 2 to the first is going to be 1 over 2. F of -2 is 2 to the -2, which is 1 over 2 squared. Right, so our reciprocal of 4 is 1/4. Right. F of -3 is 2 to the -3, so that's 1 over 2 cubed, which means we have 1 over 8 for this last value. Right. So looking at what we have here, again, I'm not going to do the first one just because it's really hard to get a point in that close. Right. We have the point -2, 1/4, so we have a dot right here. -1, 1/2, 0, 1, 1, 2, 2, 4. Right. And then if we were to think about this, 3, 8, well, that would be somewhere kind of up here. Right. So what we see is this graph that going to the left, right, we get really, really close to our x-axis. Our fractions are going to keep getting tinier and tinier. We're never going to cross our x-axis just like we did in our rational function above. But as we go to the right, notice that we start jumping very, very quickly. Right? Our next value would be 16. 2 to the 4th power is 16. And then we'd have 32, and then we'd have 64. Right? And by the time we are not even over to x equals 10, we'd be over 100 on our vertical scale. Right? So when we're thinking about these and we're looking at our exponential equations, if we have a whole number that's raised to a power, we are going to say that, right, these graphs increase rapidly. Right? So as we look at our values to the right side, we are going to increase very rapidly. All right, now to look at G, we're going to do the same thing, only this time notice that we have a fraction raised to an exponent. I'm going to do the same thing here. I'm going to start at the bottom and kind of work my way up for values. So I'm going to start at f of 3. Right? So 1/2 to the 3rd power, right, is 1 to the 3rd power over 2 to the 3rd power, which gives us 1 over 8. F of 2, right, 1/2 squared. 1 squared is 1, 2 squared is 4. F of 1, 1/2 to the 1st power is just 1/2. F of 0, anything to the 0 power is always equal to 1. Right? And if we look at these values that we have, notice that they are kind of mirror images of the ones on this side. Right? When we were thinking about negative exponents, right, we basically took these values and found their reciprocals to find our values for our negative exponents. So to get these last 3 values, right, we're just going to flip and find the reciprocal to get our negative exponents. So instead of showing all of the work for these, we're just going to say that we are going to find our negative exponents using, right, reciprocals, which means we're just going to flip our fractions. Right? So f of positive 1 was 1/2. We flip 1/2 as a fraction, well, 2 over 1 is 2. We flip 1/4 as a fraction, 1 over 4, or 4 over 1 is 4. We flip 1/8 as a fraction, 8 over 1 is 8. All right, so in this case, negative 3/8, here's our value that's going to be up very high off of our graph. Negative 2, 4. Negative 1, 2, 0, 1, 1, 1/2, 2, 1/4. So what we have here is we have an exponential function, and because we have a fraction, we're going to say that we decrease, especially on the left side, very rapidly. The last thing we're going to look at in this section is we're going to review some other stuff that we talked about in Chapter 3. We're going to focus on our linear functions because in the next section we're going to use a lot of information about our linear functions. Right? So we're told to write the equation line in function notation, identify the slope, the x-intercept, and the y-intercept. So we're going to start with our slope. Remember our slope equation, m equals y2 minus y1 over x2 minus x1. Right, so we're going to use that equation first. Right, so using our values that we have, right, this is going to be x1, y1, x2, y2. So we get 3 minus 1 over 2 minus 1, right, which gives us 2 over 1, which we can just write as a whole number 2. Now we're going to find our equation of our line, right, and again we can use our point slope form. Y minus y1 equals m times x minus x1. Y minus y1 is 1 equals m, which is 2, x minus x1, which is 1. Y minus 1 equals 2x minus 2. Add 1 to each side. Y equals 2x minus 1. This form that we have this in, this y equals mx plus b, gives us our function notation. So our equation of our line in function notation, so remember we start with an f of x instead. F of x equals 2x minus 1. We can then find our slope. Our slope is the number that's connected to our x. It's our m value, which was that 2 over 1. We can write it as a fraction or just a whole number in this case. Our y-intercept. Y-intercept always starts with 0, and it's the other number from this function form. 0, negative 1. Our x-intercept. Our x-intercept, we always have a 0 for y. So to find our x-intercept, I'm going to go back to this equation over here and use this to find our x-intercept. 0 equals 2x minus 1. If I add 1 to both sides, 1 equals 2x. Divide both sides by 2. X equals 1/2. So there is our x-intercept. So again, reviewing some different things that we looked at back in chapter 3, because we are going to create some linear models in the next section where we're going to want to make sure we are familiar with these different pieces of our equation and how to find these different pieces. All right, so let's work through one more. Right, so here is my x1, y1, x2, y2, right, and we're going to start with our slope. Right, m equals y2 minus y1 over x2 minus x1. So we are going to have 2 minus 0 over 2 minus negative 2. 2 minus 0 is 2. 2 minus negative 2 is really 2 plus 2, which is 4. 2 over 4 reduces to 1/2. Now we're going to use our point slope form. Y minus y1 equals m times x minus x1. So y minus 0 equals 1/2 times x minus negative 2. So y minus 0, which we can at this point, we'll just drop that minus 0. We'll just write that as y equals 1/2. I'm going to break this down step by step. We're going to change our signs first. So we're going to have x plus 2. Right, then we need to distribute. Y equals 1/2 x. 1/2 times 2. Half times 2 is just 1. So 1/2 x plus 1. So our function form, f of x equals 1/2 x plus 1. Our slope, our m value is that 1/2. Our y-intercept, 0, comma, positive 1. Again, the other number that's by itself in our equation. X-intercept, remember we're going to let y be 0. So we're going to go over here to find our x-intercept. 0 equals 1/2 x plus 1. I'm going to subtract 1 from both sides. So now I have negative 1 equals 1/2 x. Right. And now I'm going to go ahead and multiply both sides by 2. Negative 2 equals, these guys cancel. Negative 2 equals x. So our x-intercept is negative 2. So again, as you're looking through stuff in this section, there really isn't anything new except, aside from our graphs of our exponential equations. Right? The other graphs of our other types of equations we should be familiar with. So just make sure you familiarize yourself now with our exponential graphs. and go back through and think about how we can generate equations of lines in function notation.